Welcome again to Learning Beyond. I'm Anil Mahadik. Last time we have started on the structural drawing study and we have taken the example of simply supported beam. Today we will start with the fixed beam details, how the drawing is prepared for the fixed beams. Yes, so this was the content which we have seen last time. Structural drawing, standard drawings we can say in RCC buildings. And we have seen the simply supported beam details, the basic concepts and the drawing detailing part. Today we will start with the fixed beams. Let me share my screen. So fixed beam, all of you know, fixed beam means if you think from the analysis perspective, then we have such kind of supporting condition fixed. These are the fixed supports and we have a load on the fixed beam. So these are the fixed supports. So in this session, actually, I am going to give more focus on the drawing part, actually. Analysis part you can see in other videos. So let's say if this is a fixed beam having a load on the this beam, let's say W, then what kind of bending moment diagram we get? So we get the bending moment diagram like this. As we say it is a fixed, there will be fixed end moment at the supports also. So there will be moment here at the support and there will be moment here also at the mid span bottom. You know that the tension is at the bottom here and compression at the top, and in this zone as the moment is above the support, then there is a tension top and compression at the bottom. So you understand that the in this zone the main steel will be at the bottom and in this zone the main steel will be at the top support. So let's say what is mean by fixed beam. Actually, fixed beam is generally if the beam is supported on the column, then we can call it as a fixed beam. And if the beam is supported on beam, then we can call it as a simply supported. So let's draw the diagram of fixed beam. So let's take one simple one fixed beam actually in our problem. Let's say we have this beam and this is our column, say. And these are the columns. As it is a column, we can say it is a fixed support. And by looking at the bending moment diagram, you can say there will be steel. So as the moment is maximum at the center bottom, so we will have more steel at the central zone, and here you can curtail the bars. For example, we will provide these bars. Like so, this will be minimum 2 bars generally we provide, and then we whatever additional bars are required, we curtail them. So this will be your curtailment. So this is to take care of this MS moment. Then we will have, as there is a compression zone here, we will provide nominal anchor bars to hold the stirrups because this is a compression zone. But yes, near the support we have hogging moment here, negative moment we can say. So for that we will provide steel here, and this will be something like this. And this will be something like this. Additional steel for this moment MH. As it is a fixed moment, you know that the moment has to be transferred into the column. And to transfer the moment into the column, we should provide this L. So this is very important. Providing the L is important in the beams, in fixed beams. So this is the main steel we can say, and yes, bottom steel also you can provide a L like this and like this. Now what should be the distance of each bar? So if you look at this, if you assume that this is your span is, let's say L1 is the clear span, then this distance will be 0.1 L1 curtailment distance at the bottom. This will be 0.1 L1 And this will be from here. See column face. Look at the column face. Till this portion will be 0.25 L1. 0.25 L1. Similarly here 0.25 L1. See 0.25 L1 means generally people are knowing this L1 by 4. We can say L by 4. Generally we use this term on site. So L by 4 or 0.25 L1. And what should be the length L of the L? So this length is from this face to this portion here. This I can call it as a LD, development length. So for different diameter of bars and grade of concrete and steel, LD is different. Generally, we take LD roughly 60 times diameter of the bar. But yes, you should refer the structural drawings for this. In our structural drawing study, at the end of this series, I will give you example of practical drawing where you will see these details in the notes. So this is your LD. And yeah, and regarding the stirrup detail, we have already seen that in simply supported beam section. So stirrups details are same even for fixed beam or any kind of beam. So we have a closer spacing near the support like this. So we have more steel near the support, and as we go away from the support, then we can have more spacing of the stirrups like this. And then as again go near the support, so it will be close. And the distance is, see, if you assume this depth of the beam as D, then this stirrups, this zone, I can call it as a 2D zone. So till this 2D, you should have a closer spacing as per the structural drawing. So this is the concept of fixed beam detail. Okay. Now to extend this problem, let's take an example of continuous beam. So the continuous beam, you know the behavior of the continuous beam from the analysis point of view. Let's say we have a beam like this. So there are two aspects that, let's say I will take 3 span continuous beam. Okay. And then there is a load. So if this support is your column support, like this, whatever I told you. So if, let's say there are all columns here. This support is nothing but a column, column, column. And their beams are supported on these columns. Then once you apply the load, then there will be bending moment. As this is a column, I can say this is a fixed beam. And in fixed beam, we know that we get support moment. Then on the continuity also we get support moments. So this is your bending moment diagram. So you can understand the tension is here, then compression here, then this is the tension zone, compression, here tension. So bending moment diagram shows the tension zone actually. So here also tension, here tension, tension. So that means we will have a steel, main steel in the tension zone. So let's draw the continuous beam. So let's say this is your continuous beam. So by looking at the bending moment diagram, you can understand where is the main steel. So it is same as this fixed beam concept only. So we will have, let's say, main steel. First, we generally provide minimum 2 bars throughout with L. With L here. Then for this maximum moment at the center, we will have a curtailment. So this will be your curtailment. This will be curtailment. Okay. Now you know there is at the support we have a steel. So first of all we will draw anchor bars, minimum steel which is required to hold the stirrups in compression zone, and then we will provide main steel at the support. So you look at the bending moment diagram. So here we will have a this kind of, then here support. So we will provide additional extra steel at the support top, and here again at the end will be like this. So what will be the spacing? So in this case we will have this, as it is end, we can say it is a 0.1 L1. So yeah, let me, what is L1? So L1 is, this one is L1 for first beam, and this one is L2 and L3, then 0.15 L1 here. Okay, then see, as it is a continuous here, we will have 0.15 L1, L2 here in this, because it is L2. Again 0.15. So whenever there is a continuity, use 0.15. Here also it is a continuous, so 0.15 L3, and here as it is a end, 0.1 L3 here. And for other top support it is very easy, 0.25 L1, then here it is 0.25 L1, 0.25 L2, here again 0.25 L2, 0.25 L3 in this case. L3. So this is the detailing. So look at the bending moment diagram, and then these are the detailing. So these are generally used on the site. So generally structural engineers are giving the table of the reinforcement for which beam, what is the reinforcement at the bottom, what top, this main top anchor bars, and additional steel at the supports. And by looking at this drawing, they will provide the steel on the site. So this is the detail of continuous beam, and stirrup details are same like fixed beams. 2D zone we will have more spacing, closer spacing, and within other zone it will be loose spacing. So this is the detail of fixed beam. So thank you all for watching my video, and for others drawing details we will see in the next session. Thank you.